document. It says 0.8000, 4 decimal places. Value 1 is here, and the value 1.2500, 4 decimal places. So a generic pharmaceutical product is deemed equivalent in, this is bioequivalence. This is there are different types of bioequivalence, but this is average bioequivalence as opposed to population and individual. So anyway, it comes down to computing a confidence interval for the difference in the blood levels, in the pharmacokinetic parameters derived from blood samples over time of people, and using the branded drug and the potential generic drug. And in the end, it comes down to, all the chemical testing shows it's the same, but in the end, you have to demonstrate in vivo bioequivalence of these products. And the specifications are that your confidence interval for the mean of the generic divided by the mean, the ratio, like the difference on the log scale. The generic and the mean for the branded is about 1, right? The ratio is not very different from 1. So they're about the same, the means. So you compute this confidence interval, and that thing has to be from, has to be in this range. And it's damn specific. It says rounded to 4 decimal places. Your confidence in it, there's even a damn thing about how you have to round. Anyway, so and this is the determination of in vivo bioequivalence that gets the thing approved. And so with testosterone, it's a product that is used, the marketing people said about 1,000 times higher usage of testosterone gel supplement than is medically justified. So the public, men, bodybuilders use a lot of this product, which far more than is justified by medical conditions like men who lack natural testosterone production, hypogonadism. Anyway, so we made a generic version of androgel, and I spent maybe a month trying to develop a good recommendation for a sample size, because the same thing, this applies the same as before. We have a 90% confidence interval that has to be narrow enough under a specific alternative of equivalence, it needs to fit in this range. And it was approval of the drug, meaning this confidence interval as a chapter, whatever it is, you get 6 months or 1 year of market exclusivity as the first generic on the market, worth $90 million in the first 6 months to the company. So it was not a joke. And we were spending a lot of money on the clinical study because I think we were using the test, the female t-test. So you have about $1,000 per sample, blood sample, to compute a pharmacokinetic profile. We probably had, I don't know, 3 days worth, probably had, call it, at least 30 sample points per person. And each person in a crossover design gets the generic and they get the branded. So that happens twice for each person, and then you have however many people. So you have $60,000 per sample that this costs you. And so it was important to develop a sample size estimate that had sufficient power to achieve the result. You want to have enough samples to have a high probability of making a rejection, of detecting this alternative hypothesis. But each sample costs you $60,000, so you don't want to waste your money. So you have to balance this, and anyway. So I think I came back and I told them like 52 was my guess that made this a 90% success, 90% chance of having a good study. And then the vice president said, no, we'll do 80. He spent a lot of money, just didn't even think about it. At $60,000 for 30 times 60 grand, anyway. In the end, we got a confidence interval because there was a problem with the packaging of this thing. The confidence interval was like here to here, and this point was 1.2509 or something like that. That's $90 million at the 4th decimal place that was down the tube. We got it approved with the dirty statistics because nowhere in the document does it say that the confidence interval has to be symmetric. And so I could put a confidence interval that was much less precise. And I could pull it down to 1.2499 at this end by expanding it on this side, and that plus some other tricks, and we got the thing approved. But I guess that's just an example of where sample size and the parameters, the power, the alpha significance level, the power of the statistical test are can be worth a hell of a lot of money in where are we at? Okay, that's it for our fourth session. I didn't get to the probability stuff I wanted to, so next time I will probably try and do that of, statistical independence or independent probabilities, conditional probability, random variables, combination of random variables, joint distributions, this kind of stuff that you need to know. Thank you. You can kill it.
Gracias por conectarse a la sesión número 4 del seminario de estadística. Los estaremos esperando el día de mañana para la recuperación de la sesión del día viernes de topología. Gracias.